Okay, we'll solve a first good enough question on tree. So there is a well-known English word called as symmetric. Okay, like an array can be symmetric, isn't it? So what I mean by symmetric array is, let's say you have 3, 2, 1, 2, 1. This is a symmetric array according to me, because this is the line of symmetry. You have 2, 2, you have 1, 1. Correct? Similarly, you can have a symmetric tree also. Can you imagine how a symmetric tree would look like? A symmetric tree would be something like this. So let's say you have 10, and then here you have 9, 1, 12, 6, 5. Here you will have 9. Here you will have 12. Here you will have 5, 6, 1. This can be regarded as my line of symmetry. You have been given root of a tree. You have been given root of a random binary tree. And you have to check whether that tree is symmetric or not. If it is symmetric, you have to return true. Otherwise, you have to return false. So you have to write a function that returns Boolean. And the name of that function could be is symmetric. And what it takes in input is the root of the tree. So you have to fill in the blanks here and make this function return true or false depending upon whether the tree rooted at R is symmetric or not. You know, before we move on to the solutioning part, see, one thing is very, very true. So before your fingers work on the keyboard, your brain should work. So when you are thinking, you think fundamentally, you do not think in terms of code. Think fundamentally that what is the property of a symmetric tree. Once you are clear with the property, you can convert that property into a recursive equation and then you can code it. Correct? So what is the property? Let's first talk about the property of a symmetric tree. The left subtree, which is this, and right subtree, which is this, both of them are mirror images of each other. Left subtree is a mirror image of right, right subtree is a mirror image of left. So if that is true for any tree, then that tree will be symmetric. Even in array also, this part was mirror image of that. If you put 1, 2, 3 in front of mirror, you will get 3, 2, 1. So if the left part and the right part are mirror images, my job is done. So if, let's say I have a separate function called as R mirror image, what it does is it takes two subtrees. So let's say the root of the first subtree is R1 and second is R2, and it returns whether the subtrees rooted at R1 and R2 are mirror image or not, then my job will be done. So if you can write this, then you can just call this function from here. You can just call R mirror image for the left and the right subtrees, which is for R left and R right. And if it returns true, you want to return true. If it returns false, you want to return false. So now all that you have to do is you have to fill in the blanks here, not there. So again, you have to think in terms of root, left subtree, and right subtree. Again, the fundamentals remain the same. Let's take a look at the board. This is quite important to understand. See, if you want the tree rooted at R1 to be mirror image of the tree rooted at R2, the first thing which is important is that R1 and R2 both should have the same value. This has to hold, because the moment R1 and R2 have different values, there itself you can say that the tree is not symmetric, no need to go down. So that is the first thing which should be true, that R1 data should be equals to R2 data. Correct? But only this much is not enough. Certain other things also have to be true. And that means that the right of it should be mirror image of the left of it. So the right subtree of R1 and the left subtree of R2 should be each other's mirror images. Do you see that? Yes or no? Similarly, the left subtree of this and the right subtree of this should be mirror images. So this should be mirror image of that, and this should be mirror image of that. Now it looks like in order to check whether this is mirror image of that or not, I just need to check whether this is mirror image of that and this is mirror image of that. So this problem is again recursive. To solve bigger, you have to first solve for smaller. So what I would want is that the tree rooted over here should be mirror image of the tree rooted over here. So now this is the function that checks whether the two subtrees are mirror image or not. So I can recursively call this function R mirror image for the tree rooted over here, which is R1 right. And along with it, I can call R2 left. Correct. And also I want to ensure that this is the mirror image of that. So I need to call R mirror image of R1 left in association with R2 right. Now, for these two things to be mirror images of one another, all these three conditions have to be true. When you want all the three conditions C1, C2, C3 to be true, what operators do you use in between them? You use AND operator, logical AND operator. So you want this to be true, and that to be true, and that to be true. So you would return this expression. If this expression is true, that means the tree rooted at R1 and the tree rooted at R2 are both mirror images, otherwise not. What is the intent of this expression? Okay, any edge cases that we will have over here. So I can just transport it from here to here. Imagine it is written here only. Now there have to be certain edge cases that you need to take care about. Leaves is still okay, because let's say if you are here and if you are here, you will still check whether this value is same as that or not. And then you would want to check whether null is mirror image of null or not. And this null is mirror image of that null or not. That is still okay. The problem might arise when both of them are nulls, because see here what you are doing is you're directly using arrow operator. Now you cannot use arrow operator on null. So sometimes it might happen that this is null and that is non-null. And sometimes it can be vice versa, that this is non-null and that is null. And sometimes it can be that both of them are null. Now the point is, even if one of them is null, this thing will throw null pointer exception. So I need to take care of nulls separately. How to take care of nulls? So I can say if R1 is null, that means R1 is empty. And if R2 is non-null, that means R2 is something like that. Can an empty tree ever be a mirror image of non-empty tree? Is that ever possible? The answer is no. And the vice versa would also not be true. But if both of them are null, then I can safely say that, yeah, they are mirror images. So only if both of them are null, then I would return true. And if one of them is null and the other is non-null, then I would return false. So how I can code it, I can say if R1 is null together with R2, if both of them are null, just return true. But if R1 is null or R2 is null, then return false. And you know, I have intentionally written this condition after this condition, because if this condition is not true, that means both of them are not null together. And if this condition is true, that means either this is null and that is non-null, or vice versa. In that case, I'll return false. So this is a termination condition, that is another termination condition, and this is our recurrence relation. That's it.